Let me share my screen. You are able to see my screen, please let me know.
Yeah, I can see your screen.
So we need to discuss. Okay, before means going through the this document or going through the theory, as you know, first we will make a mind mapping and do some discussion. Am I right?
Yes.
So for this, you can say think of you have a you can say pipeline. Okay, in that pipeline there are different steps are there. Am I right?
Mm.
And each and every steps as per my you can say understanding, each and every step is different. For that we need to use
Mm.
different you can say scripts there. Am I right?
Mm.
And each and every step have a dependency or a
Mm.
relationship. Hey,
Mm.
this need to be executed after this, before this, or in between, means those should be required to
Mm.
be succeed in our objective or be successful in our this objective or this
Mm.
system. Am I right?
Mm.
For that, if you think of these things, means for each and every you can say nowadays means system are involving and they don't have a just some step, they have a multiple steps. Am I right?
Mm.
To organize all these things is a tedious task and manually you cannot think. You understand my point?
Mm.
You can think of, let's say there is a assume you have a 20 steps are there. Am I right? 20
Mm.
steps are there and they are also connected with each other. Am I right?
Mm.
And if something is failed, then we need to recover that as well. You understand my point?
Mm. Yes.
If you can say we need to maybe notify the things as well.
Mm.
Right? Or we need to, you can say, not start from beginning. We need to start whatever steps is failed.
Mm.
Okay. So based on that, we require someone who can take care of all these steps,
Mm.
all these things in a proper manner.
Mm.
So orchestration is nothing. Means coordination
Yes.
for all these components.
Mm.
So that means just initiating a cron job is not enough.
Mm.
Am I right?
Yes.
Just so it will not fulfill our thing in a you can say involving
Mm.
requirement.
Mm.
So for that we require some tool. With the help of that we can achieve that.
Mm.
So for this solution, like earlier we discussed about Kafka. Am I right?
Mm.
So Kafka is an event. We just you can say coordinate between publisher and your consumer.
Mm.
Am I right? For that thing only. But means orchestration is required. Am I right?
Mm.
So for that, Airflow comes in a picture, and you can say it's well tested, and it's you can say it's 12 by I think so. Airbeams or Airbus. I'm not able to recall properly, but and later on they will hand over to you can say community. So now they are maintaining in 2015 I think so they developed that.
mm,
and they developed because this is a pain area.
mm,
Am I right? To manually you're scheduling this a pain area, so they come with this thing. Okay. So now
okay.
and and here means right now means earlier you write scripts for each and every step. Am I right?
Mm,
So here itself we need to write a scripts or require a code there.
mm,
Okay. There, for that you need to know the language also.
mm, mm,
And there in this concept there is a term called DAG.
mm,
Okay. DAG is there. Okay.
mm,
So in this you can say DAG, you need to you can say G for you can say here this graph acyclic. I think so. What is the full form of that? DAG data acyclic. You can say this graph.
yeah. Mm,
So means here means with the what is the purpose of graph? With the help of that we can analyze the thing. Where is the you can say we are performing well or not? Am I right?
mm,
And we are means our business is going up or down. Am I right?
mm,
Directed acyclic graph. Okay, tag is directed. So means directed means as its name suggests, you can say it's a directed means how acyclic class means one have a dependency on another, another have a dependency on another. Am I right?
mm,
So there is a transaction dependency. So with the help of that graph means it's a metadata basically. With the help of that, our system can understand and
mm,
work accordingly.
mm.
You understand my point?
Yes.
And for that, we require language. With the help of that, we can define that.
Mm,
And for that, just language is not enough. We require we to use that language properly. We need have a rules there as well. Am I right?
mm,
Rules are there and means like pronunciation or this grammatic rules, and
mm,
let's say perform something good, we require operators as well,
mm,
because in a system you need to connect with the means different part require different tools, and for to work with those two you require operators.
mm,
You understand my point or not?
yeah.
Like in your this database orchestration, you require you can say need to work with the this you can say bash, you need to work with your SQL, am I right, and other things as well. You understand my point?
Mm,
So for that we require tool. So means to keep this thing all in mind, this tools come in a picture and it's providing all the required.
mm,
For that to know this tool very well, then so that we can feel confident and we design a system accordingly.
mm,
And means this is a summary of the things which we are going to discuss today. Okay. And I found this a little bit, you can say, good.
mm,
That's why I will move to, you can say, our VS Code to this
mm,
GitHub
mm,
Markdown, so that you will get a more clarity and a more, you can say this.
mm,
Okay.
mm. Yeah.
So with this knowledge, let's go, just go ahead, Ambaji, and check
Mm,
this. And if you are wherever I think I need to give a more insights, I will give you that insight. Okay.
yeah. It makes sense. Deepak. Yeah. Okay. So with that insight, topic to orchestration tool Airflow. So this is an orchestration tool, as you told, which will control the flow, job events. So whatever it is, so it will control the interdependent flow. So the goal is to moving from running isolated data jobs to designing reliable, scheduled, observable, independency aware pipeline orchestration. So what they're trying to say in this line is, if we are having a job which are running individually, from there, so we are going to make all those jobs reliable, right?
Yes.
And we can schedule them whenever we want. As per our business, we can schedule those jobs. So like that pipeline we are going to achieve with this airflow, and it is observable. We can observe the entire job lifespan, whether it pass, fail, everything we can monitor, kind of thing. And
Yes.
dependency aware. So if
Yes.
there are 20 jobs, as you said, if the jobs are having interdependency, if they all like if there are third and fourth job having dependencies, so only after user password is validated, if you are allowed to enter, and you can book a book from the library, if that is the job. So we should, until this registration is successful, we are not allowing the member to borrow the book. So if you take those things, so those things and all, we can we are aware of those dependencies. So all these things we can achieve from this orchestration tool, which is nothing but Airflow. So what is Airflow? Apache Airflow is a workflow orchestration platform used to define, schedule, monitor, and manage data pipelines as code. So Apache Airflow is an orchestration tool actually. Orchestration means we can have a complete control of all the jobs, whatever we will do. That's the awareness I have. Like we can define them. Define them means we can instruct the tool. So which job has to go first, which job has to go next, and like that we can define them. We can schedule them. So when whichever time the business demands, maybe morning hours, early hours, or late nights, those things and all we can schedule and monitor whether all the jobs failed, pass, so like that, and manage the data pipelines as a code. So everything, all these things we are achieving through code.
Yes.
So coding with code, Python code, we are able to achieve all these things. And similarly, what I will correlate this with is Azure Data Factory, Deepak. So there also we will do orchestration only in the Azure Data Factory. There also we will build a pipeline, and we will orchestrate the jobs in that. So I have little knowledge on that. Not little, I have worked on that ADF. So with that knowledge only, I'm trying to correct the dot. Okay.
Yes.
Next line, it helps teams coordinate multiple dependent tasks such as ingestion, validation, transformation, loading, alerting, reporting. Yeah, you have mentioned this, all this. So this will help to ingest. If you have to ingest data, means like data can be uh, moved, right? So those things. Could you please scroll down? Yeah, okay. Instead of manually running scripts one by one, Airflow allows. Yeah, I think your mouse has.
Sorry.
Yeah, yeah. You have to move little. Yeah, screen. No,
How?
I didn't finish that. I didn't finish that above one.
Okay.
Scroll up, Deepak, please. Yeah. So instead of manually, yes, here on the last line I have to study. Instead of manually running scripts one by one, Airflow allows engineers to define the full workflow in directed acyclic graph, nothing but DAG, where each task has clear dependency and execution rules. So yeah, which is where we can clearly define and monitor. That is what they're telling. Okay, I, I understand each and every line here, Deepak. Yeah, we can go to the second point. Why do we need the airflow? So in real system, pipelines are rarely in single script. Okay, so a normal production data flow may require extract data from APIs or databases, waiting for files to arrive, running transformation jobs, loading curated data into warehouse, triggering validations, sending alerts on success or failure, retrying failed steps automatically. All these things are involved in the production. Is exactly agree. Without orchestration, teams faces the problems like manual operations. If any failure or anything happened, they have to do manually. Hidden dependencies, yes, as I said, there will be interdependencies which is not clearly known, unclear failure points. So yeah, if there is a big job running, so and it failed, we will not be able to know where exactly that got failed. So without airflow, we will have this problem as well. So no scheduling discipline. Yes, it is difficult to schedule when which job has to run. Difficulty rerunning partial workflows. Yes, this also will happen. Sometimes the job is, if there are 10 jobs in between, the fourth or fifth job is skipped, or if it is not run, so the pipeline will stop at that point. So the time it is called partial run. So it is difficult to rerun the partial runs, and whether we have to run from the beginning or we have to run from that point where the jobs has skipped. So that is really toughest call for the production team. Poor
Yes,
observability, yeah, poor observability is also one of the point where exactly that has been failed to identify or to refer lot of logs and other thing. Yeah, airflow solves this by making workflow explicit, scheduled, repeatable, and observable. Mm.
hold on. I have a question. What you understand from this? This
See,
word, explicit.
air airflow solves this by making workflows explicit. Airflow explicit. The term is nothing but like which is not having any dependencies or independent. Any workflow can run without any dependent, and that is one
No,
meaning. One meaning. No, I'm just trying to understand the literal meaning. So workflow explicit. So in particular, if there is any workflow which is having any dependency, all those things, so we can give special care to that particular job.
I'm talking about this word. I need to understand the meaning from you. From you. What to understand from this explicit?
Explicit is, for example, if we have 4 or 5 jobs, so we 5 jobs. So I want to explicitly take care of any job. Say job number 3. If I have to monitor or schedule that one explicitly. Explicitly means in particular, and without worrying about job 1, 2, and 4, 5. So we can take special uh, care.
So basically, explicitly mean in means it's the same mean for everywhere in our you
Mm,
can say programming. Explicit means where you will tell everything by your own.
mm,
Understand?
yes.
Means you will tell the system, hey, this job have these, this workflow have these step, and they each
Mm,
and every step have a dependency on these things.
mm,
Am I
mm.
right? And this is a sequence of these things. You are telling each and everything to the system by your own.
By our own. Okay.
That's called explicitly.
Mm. Forcefully, we are defining the rules, scheduling everything.
Forcefully is a different thing.
Different.
Explicitly is saying we are we
Ours.
know these things
Mm,
and we are providing the required information in a better manner to the system.
mm, mm,
Forcefully is a thing which you are saying, hey, you don't have a choice, you need to do it.
mm, mm.
You understand?
Yeah. Okay.
So there's a difference between forcefully and explicitly.
We
Explicitly depends on the
intentionally defining all those.
yes, yes, yes.
Mm-hmm.
And tomorrow, if something is break, then we know. Means here we will define these things and explicitly we will give this instruction.
Mm.
This thing is failing, we can go there and change that. You understand my point?
Yes, yes, yes. Mm.
Okay, go
Okay.
ahead, please.
Mm. It is just like in the restaurant, we take the menu and we are telling what we want them to serve, right? So
Yes, yes, yes.
similar to that. Yeah. Okay. So point number three, when should we use airflow? So we know on all these occasions we need airflow, and when without that, what are the problem we have seen? So, now this point number three is telling when should we use airflow. So use airflow when you have multiple steps pipeline with dependencies. Yes, if there are 20 steps, more steps, which is having interdependency between them, we have to use airflow. Jobs need scheduled execution. If any real time, usually the jobs right late night, early morning, so they try to avoid the business hours. So at that time, we should think of using airflow. Pipelines need retries, alerts, failure handling. So if our pipelines having any alerting mechanism like on failure, we need to notify to the user email ID that something has failed. So at that time we should think or alerting things. So if unsuccessful job completion, also we can notify the user, or that all like pass or fail notification we have, or completion notification. And other thing is you want the our pipeline to retry. If for example there are 20 jobs in that, in between third or fourth job, due to anything, if that got skipped or anything, or it is waiting for the required server to come up, or anything can happen. So if it is not satisfied, the pipeline might fail, or the anything like the pipeline might skip. So if our logic has the retry mechanism, at that time also we should think of airflow notification and retry mechanism. If you want to implement that time, we should think of airflow. That's the third point it is saying. Fourth point is teams want visibility into job runs and history. Visibility also they want, like if they wanted to monitor what is happening with our all 20 jobs. So if they wanted to have this mechanism, this monitoring features in the pipeline, they should think, and also history. So what happened in past, like why it got failed, why some data is missing or anything, if they wanted to cross check. So history and the monitoring part. If that is the business need, then we should think of Airflow. Workflow. So next point it is saying workflow spans multiple system and tools. So our data pipeline spans multiple systems. So as we saw, like in the above examples, data is coming from multiple systems and sometimes tools like different APIs. Like if the weather report, for example, if you're getting the weather reports, also like the temperature is coming from one API, and if there is a climate details coming from another API, so multiple systems we are dependent. So at that time also we should or multiple tools maybe. So that time we can think. So you want the pipelines to be managed as a code, and everything we wanted to do all this monitoring, scheduling, everything like multiple step pipelines. If you have everything you wanted to do through code, so that time we will use Airflow. Okay, so with that, now we have to go and understand when we should not use Airflow. So ultra low latency event processing. So ultra low latency event means low latency means we are expecting the uh, response immediately,
Quickly, yes.
quickly. So ultra low means like if we want within a fraction of second, that time we can't expect airflow.
Yes.
Millisecond level streaming orchestration. So millisecond, like for example, if the live telecast of any sports event, so which expects uh, it's expect the live as soon as the event happens. That time we need a very live telecast. So that milliseconds of level of streaming and very simple one step cron job with no dependency. And if you have any job which is isolated job like one step, so cron job we can use that time. I have used this cron jobs. Yeah. So at that time we don't need. So if you have multiple jobs, then you can use. So Airflow is the strongest in batch, micro batch orchestration plus dependency driven workflow management. Okay. Next, in the fourth point, how does Airflow work? So we understood when to use, when not to use, and what it is. Now we are going to do how it is doing that. So Airflow works by defining workflow as DAG in Python. Yeah, I know this. So, our team also doing members. They used to do the programming in DAG, sorry Python, and they were working on DAG. Yeah, a DAG contains task, dependency between task, scheduling rules, retry behavior, and execution metadata. Contains task, dependency between the tasks that understand scheduling will be there and retry behavior. Okay, and the execution metadata. So whatever execution details we wanted to give, that is also there. Okay, two, three, four, five. Five things are there in the DAG. Okay. The Airflow scheduler checks which DAG runs should start. The executor decides where task will run. So we have scheduler, executor, then workers executes the task. Yeah. So it's client server architecture kind of thing. Executor decide what to run, and workers execute the task. You're able to hear me, Deepak?
Yes, yes.
I need to switch to mobile network. Power cut happened. Maybe you have to share the screen once again.
I need to share my screen.
Yeah,
Okay.
once again. I can't see actually. Yeah. Maybe you need to share once again.
Yes. Let me share. Please
Hmm.
go ahead.
Still can't see why. Still can't see your screen.
Could you rejoin, please?
Okay, I'll rejoin. Hmm. You can see now. Okay. So we understood the point number four, how it works, right? So next, real life analogy. Second, what is happening? Yeah, this is my okay. So understood. One second, Deepak. I'm trying to maximize the screen. Okay. Real life analogy. Imagine an airport departure process. Before a flight takes off, crew must be assigned, fuel must be filled, security checks must be complete, boarding must be finished, weather clearance must be confirmed. These steps have dependencies. You cannot board before the gate is ready. You cannot depart before fuel and safety checks complete. Airflow works the same way for the data system. Yes, because all these events are having interdependency, right? So,
Yes.
example, ingest order data, validate schema, transfer sales metrics, load warehouse tables, refresh dashboards, notify stakeholders. So all this will work in the same sequence. So it can't run in parallel. Like you're ingesting the order and you have to get the stakeholder notification, like first and last job. In between of it is getting delayed or anything, so you can't get the notification. If we can't send the notification to the stakeholders, so all are interdependence. Yeah, there is no doubt. Example is very clear. The workflow is not just a list of tasks. It is a dependency aware operational system. Yeah, it's a intelligent kind of thing. The pipeline is becoming intelligent and it's controlling, getting a good control. Okay. In plain English, like think of Airflow as a control tower for data pipeline. So directed is a click graph, full workflow map, task, one job in a workflow, dependency, which task must finish before another. Right? Scheduler decide when the workflow should start. Worker does the work, does the actual work, sorry, actual task work. Retry attempts failed task again. Logs will show what happened during the execution. That's what it was telling history, right? So we can store the history in the logs. Trigger start the tag based on the time or event logic. Scheduling, yeah. So Airflow is not the transformation engine itself. It is the system that coordinates when each step should run and in what order. Yeah, it's not going to transform our job, so it is just going to coordinate these job. Tell, hey, you have to go first. Hey, you have to go next. Hey, you have to start now. If anything fails, he's just kind of you can say the manager, right? So manager will assign the work in the scrum calls, and he will say like you both work together, right? So he is the one who is controlling the entire team, right? So similarly, it's
Yes.
airflow is that work, you can simply say. Or in the school, the PT sir will be there, no? He is making all the students to stand in the queue. He is the one who is instructing them, like to like if they wanted to do the some warm up exercise. So he is the one who is telling, yeah, all instruction. He is the one who is giving, and he is also monitoring whether every student is doing what he is instructing or not. So we cannot say it's a completely we can correlate, but those things we should infer like that's the same job this the Air Force is doing. Now is the main thing. So engineering concept, that's the real time analogy. We understood what is airflow, how it does, and why we need airflow, when to use it, and we also understood how it works now, and we also see the real time example also right till now. Till in the seventh point, we are going to check the engineering concept. That is the more interesting and more relevant part for us. Airflow, if you see, airflow is built around workflow orchestration principles. So workflow orchestration. Workflow means like this job has to run in this sequence. So in this order, and it is having this dependency. Those that is a workflow orchestration principle. So the core concept is the DAG here. So the heart of the airflow is basically the DAG, where which is nothing but a piece of code which has everything. Everything is programmable here. So first thing is out of the airflow is the DAG, which is a graph of task with one way dependency and no circular loops. Mhm. So it is a which is having one way dependency and no circular loop. So it is directed cyclic graph means it is going in one direction. So there is no coming back.
Yes.
So that is what we have to understand. It's one way. It's there is no there is no U-turn there. It is just straight going just moving forward. That's it. It's not to come back. Just like train, will start from one point and it will just go to the destination. It can stop in between, but it cannot come back, right? Whereas in other vehicles, we can take U-turn and we can come back, anything, right? So it's just like that. Okay. Next is task. Single unit of work such as running a SQL query, Python script, shell script, or API call, anything which is a single unit of work. Next, we have to understand what is operator, defining a task. Example, Python operator, Bash operator, MT operator. Could you please scroll down the book? Operator. Yes, email operator and a SQL operator. So operator is nothing but like defining the task. We'll have some Python email and Bash empty operator. Scheduler determines when the dog has to run, should be created, and which tasks are eligible to run. So when the job or task is in a ready state. This is the one which will schedule. Executor will control how tasks are executed. Example, sequential execution, local executor. Yeah, please scroll down the book. Scroll down. Okay, then celery execution and Kubernetes executors. So executor is nothing but which will control the task. So these many executors are the local executors, sequential, and Kubernetes also. Okay, workers,
You
as
can
we know,
think
like
of,
these are the uh,
but hold on,
actual
Ambali.
where the job logic is runs, and metadata tables stores tags, sorry, tag states, task status, logs, schedule, and operational metadata. So it's mainly the
Hold on,
storage part
Ambali.
here.
Hold on.
Triggering rules defines whether the task.
Hello, are you able to hear me?
Mm, yes,
I
yes,
am saying hold on. You can think of this executor means every means we are working on a one project,
yeah.
and in a project we have a different
Go on,
team.
Deepak.
Are you able to hear me?
Yes,
I
yes.
am saying you can think of this executor means we have a we
Can
are
you?
we have a different teams in our project. Am I right?
Mm,
DevOps team, QA team, operation team, DBA team. Am I right? And
mm,
everyone have a lead there. Means every team have a lead. So you can consider this executor like a lead to that particular part.
mm,
You understand my point?
mm,
And worker is nothing employees which is working for a specific task under that team. Okay, go ahead. Go ahead. Ambaji. Hello.
hello. Yeah, Deepak.
Right.
Yeah, I can hear you, Deepak.
I done from my side. Go ahead, please.
Okay, okay, fine. So I lost again the power in between. One second. Uh, I'm trying to increase the maximize the screen. I am not seeing the option. No, yeah, I can see the no option. It is blank, but okay. Let me open like this. Yeah. So trigger rules. So metadata is nothing but the storage part. It is telling the memory where it will save the lags, DAG status, task status, logs, all the schedules, information, everything. Next, triggering rules is where we define the task should when should run, the which has task has to run when, on failure what should happen, on success what should happen, all those triggering logic we are defining here. And then comes to retries and SLAs. So use it for resilient and operational expectation. All these things we should know. Then comes airflow architecture. So we can see the starting point is DAG, then the scheduler where we will schedule the job. Then comes the executor, which will actually control. So the scheduler will check, right? So when the job needs to start, whether it is eligible to start or what. So then it will give the information to executor. See, these jobs are ready to execute on this particular time. So based on that detail, those details will be stored in the metadata database. So with those information, then the executor will assign those tasks with these details stored in the metadata to the workers. So workers are the actual system where our job is executed. So these workers will interact with the source system to get the data, and also we can see it will also interact with the warehouse, right, where what has to be done after end of this end result. It will also send, if the end result is achieved, it will send the notification. Maybe it is failed, pass, all those things we can notify. So we could also see there is a web UI. So we can, that's a very interesting part actually. So this is the architecture. Okay, fine, Deepak. I have the understanding, got the understanding of the architecture now. Yeah, we have discussed that as well. Straight away, we can go to ninth point: airflow syntax and basic examples. So, if you scroll down, simple DAG example. So, we are importing the libraries like datetime, airflow operational Python. Yes, we have to work with Python. So, and as we are telling, operators also. We are using bash operator here. Okay. So then we are defining an extract data function and transform data function. Next, the logic is with DAG ID order batch. We are defining the DAG ID start date, date time. We are defining that is where the start triggering point. Then we are schedule. We are defining like it has this job will run daily basis, and catch up false. Catch up false. Why it is false? Okay, we'll see that later. Default arguments are retries. Two times it has to retry, and in the span of 5 minutes. Okay, so if it doesn't reach the expected result, it will wait for 5 minutes and it will retry. So tags are basically trying to group the related jobs, right? So that time we'll use tags. So it is the tags are orders, batch, analytics. Okay. Now we have studied like I mean we have understood like the scheduling part. Then now it is extract. Extract Python developer, sorry, Python operator. Task ID is extract data. Then Python callable callable extract data, extracting the data, then transforming the data, then loads the data. Okay, so
ETL.
transform ETL. Okay, next step by step explanation of the examples. Yeah, I think we have already discussed that. Yeah, we'll just quickly see with DAG. This defines the workflow boundary. DAG ID uniquely identifies date, the logical date which scheduling begins, scheduled daily, it runs on daily. Catch up is equal to false. Yeah, this we were not aware. So prevent airflow from backfilling all missed historical runs automatically. Okay, catch up false means it prevents airflow from backfilling all missed historical runs automatically. So catch up true if we give, it will automatically start and start it will get the information of the failure. If you give catch up false, it will not backfill the missed history. Mhm. That's the uh, that's the value of that key variable. Default arcs, that's the default retry behavior and other common task operations. Python operator used when the task logic is implemented in Python. Yeah, like equals to, greater than, something like that. Bash operators use it when task logic is in a shell command. Dependency chain. Is the could you scroll down. extractor, transformation, and then load. This means run extract first, then transform, then load. Yes. Important airflow concepts in the practice. DAG runs versus task run. DAG runs one full execution instance of the workflow. Task run execution instance of a specific task inside the DAG. Yeah, we understand that. Example, a daily DAG runs for 7 days has 7 DAG runs. Okay. So if we have the DAGs for Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday, so we will be having 7 DAGs. If each DAX has 5 tasks, then total task runs is 5 in a day, so 7 5s are 35. Yeah. Scheduling versus execution time. So Airflow schedules workflows based on logical intervals, not just wall clock execution. Yeah. This is important because many beginners think daily tag for May 7 processing may 7 data immediately, while in practice, the interval logic may represent the previous completed period. Yeah, execution time may vary, right, Deepak? Each task will run in a
Yes,
different time stamp, and the DAG may have multiple tasks. So
yes.
execution time is never same as the DAG schedule time. Okay. And also we need to understand retries. Retries are useful for for transient failures such as temporary API timeout, database connection issues, short storage outage. Retries are not substitute for bad pipeline design. Yeah. Then idempotency, airflow tasks should ideally be idempotent. That means running them should not corrupt data or create duplicates. For example, a load task should not insert duplicate rows each time. Each time it there is something blocking there. For that particular, I'm not able to. Each time this is retried unless deduplication or merge logic exists. Mm. So basically, we are not trying to we're trying to run the trying to avoid the duplication there. Backfill means running historical intervals that were missed. Yes, this is useful when a DAG was down for several days. A new DAG needs old history processed. A logic fix requires rerunning old data windows. Okay. Backfilling, I understand. It is nothing but we are going to rerun them.
We require information to rerun.
Mm, yes. Common real world use cases, daily sales ETL, where we are extracting sales, clean and standardize records, load warehouse fact tables, yes, refresh PI dashboards. Data lake ingestion is the second use case where we checks for source file arrival, move raw files from landing zone, validate file format, trigger transformation jobs, and register metadata. ML feature pipeline, pull fresh events, aggregate those features, validate features quality, publish features to feature store, notify model training workflow. That's the ML flow. And fourth is hybrid pipeline orchestration, where Kafka streaming produce near real-time events. Airflow runs hourly consolidation jobs, notify reconciliation, batch ensures correctness. Mhm. Airflow in your module context. Could you please increase the font a little bit, Deepak? Yes, yes. Yeah. For this module, Airflow is important because it connects the pipeline strategy view. You are not just learning how to move data, you are learning how to coordinate the data. Yes, this is the right word. Yeah. Like batch jobs, streaming support workflows, CDC downstream refreshness, validate layers, warehouse loading, alert, and operational recovery. In a hybrid architecture, Kafka handles event transport. ETL tools perform data movements and transformation, whereas Airflow orchestrate the dependent of. Can you scroll up, Deepak? There is something on the screen that stop sharing. Label is showing. Okay. So, yeah. ETL tools perform data movement transformation. Airflow orchestrate the dependent operational flow. Yeah. Common mistake one, treating Airflow as a streaming engine. Yeah, Airflow is not Kafka, Flink, or Spark structured streaming. It is orchestrated, not low latency event processing. Yes. Putting huge business logic inside the DAG. Yeah, DAG files should define workflow logic clearly. Heavy transformation logic should live in the reusable scripts, jobs, or services. Ignoring idempotency, retries and reruns can duplicate data if tasks are not safe to run. Mhm. Poor task granularity. If one task does too much, failures becomes hard to isolate. If the tasks are too tiny, workflows becomes noisy and complex. No observability strategy and using Airflow for everything. Yeah. Okay. Deep concepts for interviews. Why DAX must be acyclic. Okay. Acyclic creates a infinite dependency loops. Yes. They should be uh, Airflow requires workflow to move forward without circular dependency. Yes, we discussed that. Why orchestration matters more than scheduling? A cron job only starts a script at a time. Airflow means Airflow manages task dependency, retries, parallelism, backfills, feasibility, state tracking. That is why orchestration. Yeah. The 15.3 was trying to understand separation of orchestration and processing. Good architecture keeps this concern separate. Orchestrator decides what runs and when. Compute engine perform actual data processing. This separation improves scalability, maintainability, and portability. Operational resilient airflow supports resilience through retry policies, trigger rules, partial reruns, historical reruns. Yeah, backfilling, what we studied, alerting ingestion. Yes, okay. Intro questions, we can read that later. Or you want to me read now? Practice question, hands on lab. Mhm, You can skip this as well, right? Architecture thinking summary. Airflow teaches an important architectural lesson. What is that lesson? Pipelines are not only about data movement, yes, they are also about execution control, dependency management, operational reliability, and visibility. This is the shift from pipeline execution to pipeline strategy. One line revision notes. Airflow is a workflow orchestrator, not transformation engine. Workflow orchestrator, yes. DAG defines task and their dependencies. Scheduler decides when runs should start. Executor and workers handle the actual task execution. Yeah, actually, workers will do the actual task. Executor will just assign the task to the workers. Yeah. Retries and locks improves operational resilience. Idempotent tasks are safer for reruns and failure recovery. Airflow is best for batch and dependency awareness workflows. Outcomes after this topic, learners should be able to know explain airflow in plain English and engineer terms, define what a DAG, task, scheduler, executor is, and distinguish orchestration from simple scheduling. Understand where airflow fits in modern data pipeline architecture. Design basic dependency aware workflow for batch and hybrid system. Yeah. Yes, Deepak.